So problem 7 asks you to do two things. It asks you to find the zeros. Zeros are x's that you would plug into the equation, and the output would be 0. The f of x or the y would be 0. And the factorization is breaking this into parts. We're going to do two different things here. So we're going to start with the list of possible rational roots. So I'm going to write this down. Write small because you're going to have a lot on the paper. Possible rational roots. And you will have a calculator. So I know 253 or 273 is a large number, but we're going to take 273 and find all the factors of 273. So I just take my calculator and I just start dividing 273 by numbers. So I know I'm going to have 1 and 273. I know that 2 is not going to work, so I'm not going to bother. I'm going to try 3. Yeah, 3 goes into it with 91. I know no even number works, so I can skip 4. 5 doesn't go in. 7 works with 39. I can kind of tell 11 doesn't work. I didn't do 9. 9 doesn't work, 11 doesn't work. 13 works. 13 and 21. 17 doesn't work. 21, I obviously, if I try 21, I'll get 13 again. I think that's all of them. So even though 273 is a large number, you might have less than a number like 96 or 48, there's not that many. You do this last number and you write all the factors. Then you make a division, and then you take the front number and you write all of its factors. So the factors of 4 are 1, 2, and 4. And then we put a positive or negative in front of this, and this is what we're saying about this list. There might be 4 rational roots. There might be less than 4 rational roots. There might be irrational roots. But if there are rational roots, they're in this list. Okay? So maybe 39 over 2 is a root. Maybe 13 over 2 is a root. Maybe 7 over 1 or negative 7 over 1 is a root. But 15 over 17, that's impossible to have as root. These are the only possibilities in this list. And there's a lot of them. Now, if I didn't have a calculator, I would have to do these one at a time and do synthetic division until I get one that works. Okay, but we're going to be able to graph on this one. So we're going to go into our calculator. I'm going to use this calculator. Oh boy, I took up the whole screen. Okay, let's try to do this without taking up the whole screen. Oh man, this new operating system is already causing me issues. Well, what are you supposed to do to get this to
Drag the corner in.
drag it?
No, the corner of the notability. The notability one.
Oh god. Take the notability one.
Drag the corner of the screen. The right corner.
Right corner.
No.
Bottom. Bottom. Okay, bottom. Oh, sorry. Wait.
Drag in. The right corner.
Okay. Okay, things are happening.
And then you open the calculator.
Okay, I got it. Okay. And now what do I do with this? Drag this. Yeah, this is a much better operating system. Thank God they changed it to something that's so much easier to use. Okay. You guys like this so far? Okay. So, anyways, you have a handheld calculator, so you don't have to deal with this. Okay. For those of you on the video, they just had a new operating system. It's not my fault, okay? Okay, if you're watching the video, I apologize for the fact that I did not know how to open that immediately. Okay, so you're typing your calculator. Zoom 6 is good. I really suggest that you never use Zoom Fit. I hate Zoom Fit. I would never use Zoom Fit. It flattens the thing out too much. Now I see, these lines, and what I need to know is that this is a continuous function. It's a polynomial. I know it has no breaks or sharp turns. It's continuous. The domain is negative to infinity. I also know, since it's fourth degree, the most amount of terms it can have is 3, and the most amount of zeros it can have is 4, and I see all 4 zeros. So changing the x part of the window to see more x's, I don't need. I need to see more y's. How high do you want me to go? 100? Okay, we are at 100. Okay, how low do you want me to go? Alright, I heard a variety of things. That 7,000 was a possibility. Okay, so I did negative 200. Neither one of those is enough, but I can see a bump now, so I'm getting someplace. Alright, so let's go higher. Okay, we were at 100. Let's go 300. And then negative 200 was too low. How low do you want me to go? I heard negative 800. Okay, sounds good. No, that's not enough. 7,000? Negative 7,000? I might have overdone it. Okay? So, the problem with going this low is I could see all the turns, but one of those turns is way at the top, so I think we need to go like negative 4,000. I actually don't even really need to see the minimums here. I don't need to see the minimums. What I do want to find out is about the zeros. Okay? So, are any of these zeros possibilities for us in this list, or any numbers that you can identify? Somebody yell out a zero that they think. It just, you're just looking at the screen now. A number you think is a zero. I heard somebody say 1.5. You mean negative 1.5?
Yeah,
Negative 1.5. It looks like negative 1.5. The one between 1 and 2, I can't really tell what that is. And then, what about this one? That was like negative 3 exactly, doesn't it? Okay. So now, here's the way there's two ways to do it. You can go second calculate 0, which is not the way I would do it. And I would go left, and then I would go right, and then I would go, and you had to go on it, on your calculator, and it says the zero's at negative 3. But there's a better way. You can just go second calculate, you say I think it's negative 3, second calculate value negative 3, and just see if it comes out to be 0. So if you say I think it's negative 3, do second calculate negative 3 and see if it tells you 0. Now you could go through this whole list and try all these fractions. You could try positive 1, negative 1, positive 3, negative 3, positive 7, negative 7, positive 13, negative 13. All of those over, all of those over 1, all of those over 2, all of those over 4. Okay, let's look at this other one. You thought that one looks like negative 1.5? Negative 1.5. That's not right, is it? No. But it looked like negative 1.5, didn't it? Okay? And 3 over 2 is 1.5, so it definitely seemed like a possibility, didn't it? Okay. Now, do you have a guess for this number over here? Between 1 and 2? You don't have any guesses? 1.75. 1.75? Okay. I think it's what it is. But let's do second calculate 0 and see what the calculator says. This says 1.75. You got to ignore some of the stuff on my calculator, but yours should say 1.75. 1.75 is what as a fraction? As a an improper fraction. 1.75 is 1 3/4, which equals?
21.
And 7/4 is in my list, right? Okay, now, there are some fractions that you're not going to know them when you see them. Like, I would know if I had 0.5, that's a half. If I had 0.3 repeating, I know that's 1/3. But if you had 5/7, 5/7, I know it's not in our list, but 5/7 is 0.71428. You're not gonna be like, oh yeah, that's clearly 5/7. So there's some fractions you're not gonna be able to identify. That's one of the reasons you make a list. I need at least 2 from the calculator. I've got 2. I got -3 and I got +7/4, right? So right from the calculator. The other 2 may be irrational. They might not even be on this list. They could be irrational numbers like 3 plus the square root of 7. Okay, it's on that list because it's not irrational. These are possible rational roots. The irrational roots you don't have there. I would not give you one that has 4 irrational roots. You couldn't do that. You couldn't do this. I might give you one that has 4 rationals. You can find all 4 from the calculator. If it's a 3rd degree, you need 1 from the calculator. If it's a 4th degree, you need 2 from the calculator. If it's a 5th degree, how many do you think you need? 3 you need 1, 2 you need, 4 you need 2, so 5 you need 3. And I'll explain why as we do the problem. But I got 2 for the calculator. So these are zeros, which means if I do synthetic division with them, the remainder is going to be 0. And I'm doing 2 things at once here. I am confirming that they're zeros, but I'm also taking this thing apart. I'm factoring it. Okay, because we're supposed to do 2 things: find the zeros and factoring. I need to take it apart to find those other zeros that I don't have at all. Okay, so I add down, multiply, add down, multiply. If the remainder is not 0, either your synthetic division is wrong or you got the wrong number. All right, let's see what happens. Add down, multiply. Add down, multiply. When you get a remainder of 0, you can be pretty pleased with yourself. Because if you don't get a remainder of 0, then you got a problem. Okay? And it might just be that you do that division wrong. But so far, so good. Okay. I would like you to write this next to it. Write down x plus 3. Because if -3 is a 0, then x plus 3 is a factor. And then this answer I'm going to write next to it. And I know it's a 4. What power goes on this x? 3rd. If you divide a 4th degree with synthetic division, you just lower that degree by 1. So it's a 4th degree. I did divide by a 1st degree. I divided by this, x plus 3. So the degree goes down by 1. When you do synthetic division, that degree goes down by 1. And then I'm writing these other numbers. Okay. Now I'm going to do another synthetic division with -7/4. But I'm not dividing the original problem. I'm taking this thing apart into pieces. Just like if I was factoring a number. Don't write this on your paper. But if I was factoring the number 120, maybe I would divide it by 2 and get 60. And then I would start taking apart that 60. So that's what I'm doing. I'm taking apart this new thing that I just got. So I'm putting these numbers into this synthetic division. And I'm doing synthetic division with -7/4. I could have done the -7/4 first. This would not look the same necessarily, but the one I get in this next one would be the same no matter which way I did it. Okay, so I'm dividing by -7/4. So I bring down this 4. The way I multiply -7/4 is I divide this number by this 4 and then multiply. So that actually works out really nicely because I just get -7. Oh, positive 7 fourths, thanks, yeah. It was a positive 7 fourths, I don't know why I wrote negative 7 fourths, positive 7 fourths, for sure. We would have known, you know, much later that this wasn't working out because we wouldn't have got 0 as a remainder. This gives you negative 7. Wait, hold on, let me do this again. Wait, I divided it, this is a 7, right?
Yep.
This is a negative 28, okay, sorry. That's a negative 28. So I do negative 28 divided by 4, which is just 7. And then I multiply times 7. Is that right? It's right, right? Okay. And like I said, you can use a calculator during this. The calculator won't do all the synthetic division for you, but it'll do that. Negative 52. So I do negative 52 divided by 4. That's negative 13. Negative 13 times 7 is negative 91. And we get 0. Okay. So now, x plus 3 was a factor. X minus 7 fourths is a factor. And then, what degree is this next thing I'm writing? What degree is this? Second degree. I divided the third degree, and now it's second degree. I'm writing this wrong. Minus 28x minus 52. Okay, so the reason why I don't need more off the calculator is because when I get to second degree, I have another option, and that's factoring or quadratic formula. Okay, I can't do quadratic formula on a third degree. But whenever you get the second degree, you can do quadratic formula. That's why when it's fourth degree, you need 2 first degrees to get it down to quadratic. If it was sixth degree, I would need to do 4 divisions to get it down to quadratic. That's why the number of zeros you need is always going to be 2 less than the degree, because once you get down to here, you could do quadratic. Okay, do you notice anything about this quadratic that you can do? Yeah, they're all divisible by 4, so I'm going to take out a 4. That's called greatest common factor. Do I have all the zeros in the problem right now? I don't. Can you factor this? X squared minus 7x minus 13? No, there's no numbers that multiply to negative 13 add to 7. So that means I have to do quadratic formula. Okay? So I'm not done with the factorization, but I'm going to do quadratic formula to find the zeros of this part. And I'll write down the quadratic formula for you. And I will kind of talk through like what I would do, but hopefully quadratic formula is something that you've done plenty of times. So I do not plug everything in like I may do with an Algebra 1 student. I just do the opposite of B, 7. I have a calculator, so in my calculator, I'm gonna do, I mean, maybe I'm gonna do it. This looks demented, but whatever, okay. I can't see all the buttons. So I could do, in my calculator, negative 7, make sure you put in parentheses squared, minus 4 times A times C. $101? Okay, you get 101. Now sometimes that number can be simplified, but 101 is a prime number, I believe. You can't divide 101 by anything. So, you know, I can't really simplify that over 2 times A. So, because that 101, it's not the fact that it's a prime number, it's just that whether it's square root of 12, where you can't simplify, or square root of 101, if it's not a perfect square, like 100 is a perfect square, this is irrational, okay? So even if it was something like 2 plus the square root of 18 over 9, where I can simplify square root of 18 and make it 3 root 2, that's still got a root in it. So these answers are irrational, okay? Irrational means it's a non-terminating, non-repeating decimal. It wasn't in my list because my list was not about irrational numbers, my list was about rational numbers. So 7 plus the square root of 101 over 2 is not on my list. On the calculator, watch this. Okay, go to my graph. I kind of mess with this graph. But I'm gonna go second calculate value, and I'm gonna put in parentheses 7 plus, you don't have to do this, you can just watch me, 7 plus the square root of 101, close parentheses, divided by 2, and the y value is going to be 0. Now, I don't know if you can tell on mine, but it does that e thing, e to the negative 13th, so it doesn't hit 0 exactly, but you can see on the graph that looks like a 0, right? So we would never have found that, we would never have found 7 plus the square root of 101 over 2 on the calculator. We would only get rational ones. All right, so let's wrap it up here. Let's list all the zeros. We had -3, we had 7/4, and we have 7 plus or minus the square root of 101 over 2. These are the official list of zeros. Then there's the factorization. Not every problem's the same. Sometimes you only do one synthetic division. Sometimes you could do 4 synthetic divisions. Sometimes you get one rational and 2 irrational. Sometimes you get no irrational. If you do get irrational, they come in pairs. So you won't get 1 irrational, you'll get 2 most of the time. Sometimes you could do factoring and you don't have to do anything with the calculator. So not every problem's the same. Okay. I'm gonna put the 4 out in front. And I'm gonna write this down. This is an acceptable answer, not the best answer. This one, with the 4 in that quadratic, that one would be marked wrong. Okay? You follow me so far? Okay. But this is not the best answer. Okay? I would accept this because I'm nice. Okay? So you can tell your friends that I'm nice, but I would accept this because I'm nice, but it's not the best answer. When I made this problem, I did not write this down, multiply it out, and figure this out. I wrote something else down, okay? This x plus 3 is fine. I can't do anything with that. This x squared minus 7x minus 13, I can't really do anything with that. But I'm changing that middle one. Does anybody have any idea what I'm going to change that middle one to? It's not a coincidence that this is a denominator of 4 and this is a 4. If you distribute a 4 to this thing, it comes out to 4x minus 7. That's the problem that I wrote down when I made this. I wrote this down, I multiplied it out, I expanded it, and I gave you the expanded version, and I knew that -3 and 7/4 are going to be from the calculator, and I knew the other part was going to have irrational answers. And so that's how I built the problem. Sometimes it helps to know where I got the problem from, okay? You can do this at home with your friends. You can make up your own binomials and trinomials, multiply them all out and give it to your friend and say, hey, factor this, find the zeros, and you guys could do it. It's like a game, okay? Find the zeros. You ever play that game? Okay, well, you could do that, okay? So I multiply this out. Now, if you make a mistake multiplying it out and you give it to somebody and you make it impossible, then that's not fun. But this is where the thing came from. So a lot of times this will happen. The 4 belonged in here. Okay. Let me say something about quadratic formula to you that you might not have thought of ever, and I want to explain it to you so that you'll get one of the faults of quadratic formula, and it might make more sense out of what I'm saying here. 2x squared plus x minus 15, okay? Let's say you have this and you're trying to find the factorization. Now this one's factorable, but let's just do the quadratic formula. I do negative b plus or minus the square root. I'll do the b squared minus 4, I see on my calculator. 4 times 2 times negative 15 is, oh man, I must have messed this one up. Like 2, 6. Oh wait, b squared minus 4, I see, hold on a second. B squared minus 4 a c hold on 121. Okay, sorry, I kept messing it up. It's 121 all over 2 times a. Okay, so then I would go negative 1 plus 11 over 2, and I would say x equals, and I would say, okay, negative 1 plus 11 is 10. 10 divided by 4 is 5 over 2. And then I would do negative 1 minus 11, which is negative 12, which gives me negative 3. Okay, so you do quadratic form, you get these. Then some people would say, okay, so the factorization is x minus 5 over 2 and x plus 3. So if you try to do a factorization from quadratic formula, you will get the 2 zeros, and they will be right. And this might look right to you, but if I multiply this out, it would not be this. Because that 2 just disappeared, it vanished. This 2 is gone now. That 2 has to be multiplied into this one, because this is the correct factorization.